Hello, Kevin Culp from Super Micro. Today's simulation is performing life cycle management of a Gaudi 2 system. We have a number of racks that are associated with a Megapod. In our simulation, we're just going to show you one rack. Due to the number of Gaudi 2 systems we currently have in the demand, we can only show you one standalone cluster member that's part of the rack in our simulation. So today we'll show you creating of the rack, associating the rack to a Megapod. In this case, you may have several racks that are grouped with a Megapod, and many Gaudi systems that are across different racks. So we'll also go ahead and perform lifecycle management of the Gaudi 2 system, showing you all the various lifecycle icons that are available with it for the Gaudi 2 system. In later videos, we will show you how to deploy an OS to a Gaudi 2 system, and then also perform some type of GPU performance metrics collection. So let's get started. So we'll log into the SCC platform. That is the right fit for performing lifecycle management or enterprise management for Gaudi 2 clusters. So we'll log in as admin. And then we'll be taken directly to the dashboard. So we're logging in as global admin here. And we'll be taken right to the dashboard. The dashboard is a high-level view, 20,000 foot view of various different technology buckets that we expose within the dashboard itself. So we're going to go into pod view, and in pod view is where we're going to create the rack and associate the rack to the pod or the Megapod. So the first thing we're going to do is come over here and let's look at what we currently have in this environment. We have already a Gaudi 2 rack that's been created by one of our developers, and we've been doing some testing on CDU and PDU. You can see here that we have an electrical socket to represent the PDU itself, and then a water droplet to provide exposure to a liquid-cooled rack. So we're going to come over here into the edit mode, and the first thing we're going to do is use the drop down to create a group. And the group, we're going to call it as a Megapod. And you'll notice here that it automatically gives you a color coding of the rack, or excuse me, the group when we create it. You can add additional ones and keep going through the list of creating several groups that you want to create. Maybe it would be a Hadoop cluster group, could be a VMware farm group, so on and so forth. But let's just go ahead and create one. We're going to save it, and then we have success there, and you can see here already that there's a different color or a pod that is associated called Megapod. We don't have any racks associated. The default here is no racks, or what we call 5 racks that are not associated with a pod. In a new system validation, we have 1 rack that is associated with a pod. So the next thing we're going to do is go ahead and create a rack. And the rack location, we're going to give it as, say, building. We're going to call it Gaudi 2 cluster. And let's say it's in building 9, floor 2. And then the description we're going to call is a Gaudi 2 cluster. And we have the ability to create a rack size of 12 24, 42, 52, and 58. My gosh, 58, I think you would need a step ladder to get servers up there because it's a pretty large rack. Hopefully with these large Gaudi 2 systems that you have some type of lift mechanism that you can place them into the rack for your own safety because they can be typically very heavy itself, or looking at possibly having 2 people help you rack it within your rack itself, or you can use L11 and L12 deployment services for our rack integration team, which do a superb job of creating and cabling the environment for you for racks and performing testing and integration services for you for white glove. So we're going to choose option or the 42 size U, and then we're going to go ahead and click Mega Pod. So we have, again, one pod that's created called New System Validation Group. And then we have the default pod, which is always there with racks that are associated with the default pod, which is no pod at all. So you can either create a rack that has no pod associated with it, or you can take a rack and associate with a pod. So we're going to create the Megapod as the rack to be associated with. And once we do that, we have success. And you can see here that now we've created the rack. Now we don't have anything inside the rack or associated with it at all, is because we haven't taken or went through discovery to show our Gaudi 2 system that's been discovered. So we have to register it within the drawer configuration of this rack. So these numbers that are starting at 1 represent the rack slot unit. That would go up to 42. And if we're utilizing any rack space slot units at all in the rack, we wouldn't go ahead and be able to utilize those, right? Because we count the number of available slots within the rack. So on the right hand side here, you can manually add in your systems and associate them with a rack, or you can perform what we call device discovery. Now there's 2 types of device discoveries that we have implemented under the SCC scalability release. In the 2.x release, we had SSDP capability using universal plug and play, which is the standard that Redfish has standardized in. We have standardized on that with all of our BMC. So by default, SSDP is enabled on our BMC platforms. And then you certainly can go out and perform device discovery through SSDP as long as SSDP is enabled for that server. But in this case, we're going to do slightly different type of use case. We're going to provide a range of a IP addresses, so sort of like a ping spray to go out and discover those. You can see here by clicking on each one, we can use the range command or SSDP depending on how we're going to discover the appliance. So the IP address we're going to go ahead and discover is 10.184.17.253, and you could start at 10.184.17.1 to 253. That would actually discover systems in that range, but because we're just going ahead and device discovering on one server, we're going to utilize the 253 here as the last number, and then we're going to hit submit. And then when we hit submit here, it's automatically going to go out and discover that particular appliance. So you can see here where it's providing discovery mechanism here based on our cloud icon, and then it will go out and discover this particular device. So now it's discovered our Gaudi 2 system. So if we hover over there, it shows us the serial number of the Gaudi 2 system, the SKU of SYS-820GS-TNR2, and the IP address. So we want to take this particular Gaudi 2 appliance and associate it with this Gaudi 2 rack. So we simply click here, and at that point we will come into what we call the drawer configuration. And in the drawer configuration, we've actually had our agent pull metadata directly from the BMC. The BMC is our source of truth. So some of this information was pulled from the BMC itself through a Redfish query looking for endpoint data. We want to kind of associate the group name now with Megapod, because we want to take this particular appliance and associate it with the Megapod group name, and then the rack location for dropdown is Gaudi 2 cluster BN floor 2. So if you had multiple racks that are associated with the Megapod, they would be listed in the rack location availability here. So the next thing we're going to do is associate it with a rack slot unit itself, or the starting position. We call it the RSU. So we have 1 through 42 that we can actually utilize here. You can scroll down here and eventually see 42, so on and so forth, all the way down. But in this case, let's go ahead and choose rack slot unit 8 as the location, and then go ahead and save. So when we save it, it immediately now associates that rack to the Gaudi 2 rack itself. And so at this point in time, the agent is now collecting additional information called our PSME agent to make this particular Gaudi 2 appliance associated with the compute list or the element list that I'll show you to be able to perform lifecycle management. So if you wanted to change some things here in regards to the rack, so let's do some discovery while that's kind of cooking in the background. We'll come back to the view mode, because I actually you can toggle between edit mode and then view mode, right? That's how you get into discovery. Shows you the last time and when we last discovered something. And so going back into view mode now, we can come down and drop down into the Megapod itself. So we have hierarchy here. You can see now that the Gaudi 2 system is associated with the rack. So by doing here, and you see here it's in an X type of condition right now because the agent is still collecting information. So you can click on the 8 here and scroll up into what we call slot number 8, which is the drawer configuration, and then up to the rack level, which shows you the information that we just discovered for this particular appliance, and then to the Megapod level itself. So here we're at the rack level. If you needed to add in PDU information, you would do so here. So let's go ahead and change this a little bit more so we can see associating racks. You can add the PDU information here. In our case, we don't have any PDU information selected. So we're sitting at 80%, so we get a better view of what we can look at here. And then if you go to the Megapod level here, of course, you go back up into showing you the group itself and how it's or this rack is associated with this Megapod. itself. So this sandbox happens to be in Bata in Taiwan, so it's a little bit slow in rendering the information across the Pacific here. But you can see the scale in which we test on in our environments here. So let's go ahead and look at now the compute list. Let's see if that information has been added into the Gaudi 2 system itself. So we can go ahead and if we had a large tree element list, we could plug in the IP address of that Gaudi system. And oops, I made a typo there. There we go. So we still see it in an X type of collection mechanism right now. So we're still collecting vital information through our PSME agent itself. If we were to click on here, you can see it's still not under management control yet. So we'll wait for a couple of minutes here to collect the data that needs to be collected. We see some information here already indicating that this system has already been composed. So our developers are testing this particular Gaudi system for OS deployments itself. We see some basic information here such as IP address itself, discovery state, array state is for simplified storage. This Gaudi system is part of the GPU family itself. It's power on status. The health is good. We've collected already socket information associated with this Gaudi 2 system, and then memory size. And then you can look on the top here is all our lifecycle management buttons that you can perform with this Gaudi 2 system. So deep discovery, Kumakar discovery, that is for our unified fabric director for PCIe switching. This would not apply to this use case itself for this server. Deployment or allocation of an OS, so OS orchestration. Tag management, so you can define your own tags when you deploy an operating system to a server such as Gaudi, and it was in an Ubuntu kernel that you deployed or some other type of Unix flavor, it would automatically tag with the type of operating system that was deployed automatically itself. Perform power management of this Gaudi 2 system. Blink the UID, which is the blue button to identify where it's physically located in a rack or in the data center. Perform erase system, which is simplified storage, so performing an erase of the drive itself that's contained inside the Gaudi 2 system. Perform BIOS updates and BMC updates. Connect into the IKVM of the Gaudi 2 system. Connect into the BMC itself. We can look at detailed information, so we have to select it. Look at detailed information showing you the Redfish endpoints that we've collected here. So things like system information, status, boot options, processor, memory, resources, and then also the resources are the Redfish endpoints that we've collected itself, and then essentially links to show you the chassis manager and chassis itself. So these would be Redfish information. As I mentioned, our platform is Redfish compliant. So all of this information is harvested through what we call endpoint schema Redfish collection. All right, so let's refresh this and see if the server has come back to us with the metadata we're looking for. All right, so let's come back here now. We've composed this node, so there was an operating system already deployed to it in our compose node section. And then we also have health rollup is good, not a critical status. So let me give you the compose node. So if we come over to this icon here, it shows that this Gaudi 2 system has been deployed. And there's some interesting information we can collect from the Gaudi 2. We see that there's an NVMe drive of 960 gigabytes. And then we also have some manufacturing information. Obviously, being a Supermicro platform, we're showing the manufacturer, the SKU information, CPU module, local storage, and also details that you can click on itself. So we might want to click here and look at the platform itself, right? By clicking here, we're showing data associated with this Gaudi 2 system. So we're showing the front view and the rear view, physical asset information here, showing the IP address. By clicking here, you could get into the IKVM of the BMC of this Gaudi 2 system. If you wanted to perform any lifecycle management specific to the server, you're welcome to connect into that IKVM to perform your lifecycle management. But we believe here at Supermicro, managing your infrastructure through the management plane is important. So we're trying to minimize the number of clicks that you need to perform to get into IKVM. Most of the functionality can be done through the management platform itself, not having to go into the server specifically to perform those lifecycle management tasks. Product family, GPU family, SKU, serial number, BIOS version, BMC version, tag management, whether you had a RAID card in here. All very interesting information with this server, a Gaudi 2 system. The other thing is in the carousel view here, we provide a high level of what's inside the server as far as slot information, core, CPU. If this server was attached through some type of network fabric through our unified fabric directory, we would expose that. If you're performing any lifecycle management associated with storage, such as NVMe over Fabric, or attaching through a JBOF type of system or appliance. So also here, you can see a lot of these are grayed out. So I talked about compliance and governance in other videos that were something we implemented. So part of our vision is the need to know, right? So we only provide various asset collateral information to certain role-based access control of users. So this is important from a compliance and governance perspective for enterprise. So these are essentially safeguards that we built into the platform or rules of engagement. So we already have a system that's already deployed through an operating system. So we wouldn't allow you to go ahead and deploy another OS to this server. It's already been locked in the pool. We don't want to allow users to clobber the OS that's already there. So we have checks and balances in place and safeguards to prevent that from happening, so you're not shooting yourself in the foot there. So that's why they're grayed out itself. And let's come down to the corner here on the bottom and hit the navigation. So maybe we want to see what's inside or what components, or look at more detailed information about the server, such as the processor, right? CPUs 1 and CPU 2. It's a 2-socket server with 40 core each, showing you a high-powered CPU that's inside this GPU, or excuse me, this GPU server. The memory itself, it's got quite a bit of memory in here. It's got 512. We show slot identification of each DIMM that's inside the server itself. So this is showing you NUMA regions for both CPU 1 and CPU 2. So if I wanted to collect information of NUMA region CPU 1, I could click here and show you the information that's there. And then and CPU 2 as well, right? So there's a differences in what memory we've provided to each of the NUMA regions. So this is just a use case of what they provided as far as getting from the technology enablement team itself. So that's why you see differences in the memory. So you typically would want to balance the memory between each of the CPUs. Part number, size, device type, all is there, showing you information about this server and collecting vital information of what's inside the server. The ability to go ahead and look to see if we have local storage. So we have a simple drive in here, as I mentioned, NVMe drive. We see the size capacity of it. We provide information in here for link speed and various other information. On the top here, if we wanted to provide some type of RAID capability for RAID 0, RAID 60, typically that would be in a storage server, but maybe perhaps you wanted to RAID and do some type of RAID functionality within the platform itself. That's all available through Redfish and allow you to perform that lifecycle management for each RAIDed drive itself. So assuming you had a SAS or SATA drive in and not an NVMe drive. Remote storage, iSCSI storage, different use cases if you wanted to attach drives across some type of network fabric. iSCSI storage if you want to perform a boot from SAN operation. And then adapter information. So we show here NIC information, showing you all of the data here, such as link state, where we are. This happens to be in 4 AOC LAN cards or ports here. So we show the model type and the serial number. And the big one here is showing you GPU performance information, right? Or excuse me, GPU physical asset collateral. Showing you the slot ID identification of where these GPUs are located in the PCIe slot of the Gaudi 2 system. Showing you serial number, lanes, it's Gen 4, part numbers, so on and so forth. And if you want to break down additional information, if there were anything to do with ROM version, memory manufacturer, memory part number, we would provide that type of metadata there. And then moving down to the FRU and the DMI. So the FRU is, again, information if you wanted to have to replace some type of motherboard in the DMI. We allow you to change that information here if you had to have an RMA replacement for various different components within the server. So we allow you to make changes here. In this case, it's grayed out. Why is it grayed out? Because again, we're instituting compliance and governance associated with this Gaudi 2 system. So we would not allow you to manipulate any of the attributes in the FRU or DMI because we have an operating system already deployed. If the server was reporting critical health, we wouldn't allow you to deploy an operating system. We would have you go fix the server first before deploying the operating system itself. So again, as I mentioned, rules of engagement, compliance and governance, or checks and balances we have in place that we institute in SCC. So that's pretty much the lifecycle management of a Gaudi 2 system itself. So we touched on how to create a rack, associate that rack to a megapod. Maybe you have many racks that are associated with a megapod. In our simulation here, we had one rack. We associated one cluster member to that rack. Maybe those would be many servers associated across many racks that we would visualize in our pod view feature set within SuperCloud Composer. So next video, we'll look at deploying an operating system and also performing performance metric collection of this Gaudi 2 system. So we'll see you next time. Thanks for joining.